This morning, we're really lucky to hear from Kate Marvel, who, as many of you know, is a renowned climate scientist. And in that work, she has seen the world come to an end many times. Thankfully, so far, only in her computer models. Today, Kate will be talking to us from the perspective not just as a really talented scientist, but also as an author. In her recently published book, also featured here, Human Nature, the 9 Ways to Feel About Our Changing Planet, Kate explores something as real as climate change itself, and that is the emotions we feel living in a changing world. So please join me in welcoming Kate to the stage with a huge round of applause. Thank you.
Hi, folks. Thanks for getting up so early to come to this amazing event. So I thought I would start with a little bit about me. So I started my career as an astrophysicist. In fact, I thought I would study cosmology, which is literally the study of the entire universe. And while I was in graduate school, we discovered the first planets orbiting another star. We have since discovered 5,000 other planets. There are 8, maybe 9, if you count Pluto, planets in our solar system. And because I have this background in astrophysics, I speak with authority. You can believe me when I tell you that what the science says is that every single other one of these planets is garbage. The only planet that matters, the only planet where life exists to our knowledge, the only planet where it is possible to have fun, is that place right here. This is the famous pale blue dot image taken by the Voyager spacecraft looking back as it exited the solar system. So think about that. Everybody and everything that you love lives right there on that tiny pale blue dot. People talk about going to Mars. I'm sorry, do you guys understand how boring Mars is? The people who say that they want to go move to Mars will not even go to New Jersey. No other planet is an option here. And so I became an Earth scientist because I realized that of all the universe, this right here is the only good planet. This beautiful pale blue dot, this blue marble, this amazing world. But I realized that I have a conflict of interest because everything that I care about exists on the object that I study. And I realized that I felt things. I felt things when I saw the Earth changing. And for a long time, I felt really bad about that because should scientists have feelings? Aren't we supposed to be objective? Aren't we supposed to be neutral in order to maintain our credibility? And then I realized, you know what? Pretending we feel nothing doesn't make us credible. It makes us liars. And I don't want to be a liar. And so what I wanted to do in writing this book, and what I decided to do when talking about climate change more broadly, is actually talk about the things that climate change makes me feel. And the first emotion, surprisingly enough, that comes up when I think about our changing planet is not grief or anger or fear, the emotions that we associate with climate change. The first emotion that comes up is actually wonder, because climate science is still science. And that means I get to go to work every day and discover something new about this amazing world. And that provokes in me a real sense of wonder, because we do know so much about this beautiful, amazing, wonderful planet. We know why our planet has a temperature in the first place. We know that all of the energy on this planet, with the minuscule exception of nuclear reactions generated on the Earth's surface, 99.99% of our energy comes from this mediocre little star that we orbit. It comes from the sun. Now, most people know, or you learned in grade school, that the sun is 8 light minutes away from us. And that means that light from the sun's surface takes 8 minutes to reach us. But what most people don't know, and what I think is beautiful and profound, is that that light is generated by fusion reactions deep in the sun's core. And because the sun is so hot and so dense, it takes those photons, those little particles of light, 100,000 years to get out of the sun and make their way to us. So every time you go outside and you feel the sun's warmth on your skin, you can know that that light was generated before you or your parents or your ancestors or your civilization ever existed. So the sun is a powerful source of energy. But the thing that really blows my mind is that the sun is not powerful enough. If the sun were the only thing heating our planet, we would be an ice world. Our average temperature would be well below 0. It wouldn't be warm enough to support life. And the thing is, we exist only because the sky does. A tiny proportion of our naturally occurring atmosphere, less than 1/3%, is greenhouse gases. It's water vapor. It's carbon dioxide. And these greenhouse gases are incredibly sparse, but they're incredibly powerful. These sparse little molecules are sufficient to raise our temperature by trapping heat escaping from the Earth's surface. This blanket is responsible for raising the Earth's temperature from well below freezing to about 60 degrees Fahrenheit. So it is the greenhouse gases in the atmosphere that determine the planet's temperature. They are the things that allow us to exist in the first place. So think of how powerful these gases are, that a tiny, 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 sparse little amount is enough to raise our temperature so much. Now, imagine what happens when we increase their concentration. We don't actually have to imagine that because we know. We have known this stuff for over 100 years. None of this is new science. The greenhouse effect was first discovered by a scientist called Eunice Newton Foote in the 1800s. Now, we don't really have pictures, verified pictures of Eunice Newton Foote. We do have pictures of the guy who's generally given the credit for discovering the greenhouse effect. This is John Tyndall. John Tyndall wrote a lot of papers in the 1800s establishing that carbon dioxide was a greenhouse gas and showing its role in warming the temperature of the planet. He's often given credit. His wife, Louisa, who assisted him in a lot of his scientific research, is generally not given credit because he insisted that women could not do science. And I think it's important that we remember Louisa for her contributions to science and also for the fact that she ended up murdering her husband. So we have known about the greenhouse effect for a really long time. We have also had climate models, little digital planets on a computer that we can do experiments with. We've had those for sufficiently long that we can actually go back and we can look at their predictions and we can see how well they did. So this climate model from the 1980s actually did an incredible job at capturing the temperature rise that we have actually seen. And you might ask, who made this climate model? Was it NOAA? Was it NASA? Was it the UK Met Office? No, it was Exxon. ExxonMobil had a thriving climate research program in the 70s and 80s. They knew. They cannot claim that the science is unsettled. They cannot claim that they had no idea what selling their products would do. ExxonMobil and its ilk knew, and they lied. And that is the history of science. It's scientists like me finding things out and then other people lying about it. And that makes me angry. But I also feel guilty. I feel guilt both in the legal sense, because I am responsible, and in the moral sense. So how do we know that it is us causing climate change? We know that the temperature has risen. We know that it is about 1.4 degrees Celsius warmer than it was before the Industrial Revolution. But scientists do not take the process of attribution lightly. We think very hard about the natural things that might have changed the climate. So climate deniers love to tell scientists that the climate has always changed. And we're like, we know, we told you that. And it is true that we are aware of many natural things that can affect the Earth's climate. So natural climate change. For example, 21,000 years ago, where we sit right now would have been covered with a giant ice sheet. And that's because during the last glacial maximum, the peak of the last ice age, it was about 5 to 6 degrees Celsius colder than it is now. And we know why. The Earth goes around the sun, and it wobbles a little bit in its orbit as it does that. So over the course of tens or even hundreds of thousands of years, the orbit can go from a perfect circle to an ellipse. It can tilt on its axis, or it can precess around that axis like a spinning top. So we know that changes in the Earth's orbit can change the climate. And so is it the orbit? That is a valid question to ask. We know that all of our energy comes from the sun. So if the sun is getting hotter, that would explain climate change. We know that volcanic eruptions can change the climate and have changed the climate throughout history because they spray so much gas and dust into the stratosphere that they block the sun. This has happened several times throughout history, notably during the eruption of Krakatoa in the 1800s, which caused beautiful sunsets and made a lot of people freak out quite a lot, and most recently in 1991 with the eruption of Mount Pinatubo. So we know that volcanoes can have climate impacts. So it's reasonable to ask, is it volcanoes? And we can do this counterfactual in a climate model. We can run a climate model with just orbital changes, just changes to the sun, just volcanic eruptions. And what we can see is that while the volcanic eruptions that have happened over the historical period have led to temporary cooling, changes in the orbit and changes in the sun cannot explain the warming that we have seen so far. So the warming cannot be due to natural factors. So it's not volcanoes, it's not the sun, it's not the orbit, it's us. Humans do many things to change the planet. What we tend to think of pollution, the stuff that blocks out the sun and makes the sky gray, scientists call that stuff, those particulates, aerosols. And aerosols actually have a large-scale cooling effect. We can see during industrialization, aerosols served to cool the world a little bit. But that cooling effect is very much canceled out, and then some, by greenhouse gases, by human-emitted greenhouse gases, methane, nitrous oxide, carbon dioxide, F-gases. And we know, because we know how powerful those are, that greenhouse gases warm the world. So we can put this inside a climate model, all of the impacts of the things that human beings have done. And you can see that when we incorporate those things, those emissions, we get something that matches the temperature rise almost exactly. So this is how we can be so confident that it is indeed us. But here's the thing. It's not all of us. The United States right now, as a country, emits less than China does. But because carbon dioxide is so long-lived in the atmosphere, you put carbon dioxide up there and it stays for hundreds or even thousands of years. That means it is the cumulative carbon dioxide emissions that matter. And so over our history, the United States has emitted more and is therefore responsible for more carbon dioxide emissions, for more climate change than China. And when you take into account the past histories of colonialism, who was actually responsible for the decisions, the emissions decisions, when you take those into account, you find that the United States, followed by China, followed by mostly wealthy and developed countries, is primarily responsible for the climate change that we have observed so far. So a lot of times when people think about climate change, we're talking 1.5 degrees Celsius, 2 degrees Celsius. That doesn't sound scary. And sometimes during the winter, that actually sounds like it might be kind of pleasant. But I don't think about climate change like that. I think about climate change as a real perturbation, a change in the energy budget of the planet, an enormous amount of energy that has now been trapped. And that makes me scared. It makes me scared because I understand the physics of what a temperature rise might mean. We know that as it gets hotter, heat waves become longer, they become more frequent, they become more severe. That's something that falls very, very, very obviously out of the science of a warming planet. So climate change means hotter heat waves. But at the same time, warm air holds more water vapor. And that means that when it rains, it pours. There's simply more water in a warmer atmosphere that can be dumped on us. And so climate change also means more extreme rainfall, more heavy precipitation that can in turn cause devastating floods like we have seen repeatedly over the last couple of years. But at the same time, warm air is thirstier air. So even though climate change is causing heavier rainfall, climate change is also causing more evaporation from the surface, which is leading to higher drought risk at the same time. Warm water is hurricane food, and that means that as sea surface temperatures warm, they provide fuel for stronger hurricanes. We don't necessarily think that climate change is going to lead to more hurricane formation, but we do know that the hurricanes that form will tend to be stronger and will tend to intensify more quickly, which makes it more difficult to predict them. Now, fires, wildfires, are a really complex thing because they depend on human decisions, where we build, how we suppress fires, how we put them out, what the fuel looks like. But we do know that climate change is leading to an increase in fire weather, those hot, dry conditions that are very conducive to wildfires. And we know that climate change means sea level rise, and there's two reasons for this. One is there is a lot of ice currently parked on land in the form of glaciers and ice sheets. And as it gets hotter, ice melts, and that ice is running into the sea. But we also know that warm water expands. And so as the seas get hotter, they rise because of this expansion. And both of these things together lead to higher seas. So those are things that make me afraid, that fall out of the physics. But the things that make me even more afraid are the social impacts of climate change, the things that cannot be explained by a physicist like me. In the 1600s, there was a series of 4 volcanic eruptions clustered close to each other, just by chance. And this led to a cooling of about 0.5 degrees, especially in Northern Europe, which is called the Little Ice Age. Now, during the Little Ice Age, we start to see a real spike in the number of women, especially, who are being accused of witchcraft. And if you look at what those women are being accused of, it's messing with the weather. It's causing storms in the North Sea. It's killing crops. It's killing livestock. And so I am not saying that climate change today is going to lead to an increase in witch hunting. But what I am saying is that human beings are unpredictable. We don't fit in equations. We don't do what we are supposed to. And so the thing that scares me the most about climate change isn't those heat waves or downpours or droughts, even though they are very scary. For me, the most frightening thing about climate change is what it will make us do to each other. So at this point, people are usually very bummed out. And they ask me, Kate, is there any hope? Or Kate, what gives you hope? And most people in this room, most people in the climate space, will be familiar with a question like this, right? And my answer is simple. I don't need hope. I think we should abandon all hope. Because for me, that's the wrong question. It's like asking somebody, hey, do you hope you can clean the bathroom? Right? I don't know, just clean the bathroom. You know what to do. And we do know what to do when it comes to climate change. This has led to a lot of fatalism, though, right? So this article came out in 2019 in The New Yorker, and it's written by my arch nemesis, who I've never met, Jonathan Franzen. And in this article, he said, what if we stop pretending? Climate change is real, it's happening, there is nothing we can do, so let's just not do anything, sit back, and wait for the apocalypse. And I thought that this was a little silly. I thought that this was not supported by the science. And so I went to Scientific American magazine and I said, hey, we really need a scientific response to this. Will you let me write one? And they said yes. So this is the thing that I am the most proud of that I have ever done in my career. I still cannot believe they let me run this headline. And I think that's really important. It is really important to push back on narratives of doom. Because sure, you can have hope. You cannot have hope. Who cares? We know what to do. There are so many things that we can do right now. We know that climate change is caused by human-caused greenhouse gas emissions. And what's more, we know exactly where those greenhouse gas emissions are coming from. They're coming from the way we get around. They're coming from the way we cook and heat our houses. They're coming from the way we generate electricity, the way we use our land and what we eat, the way we manufacture things. And we have solutions for every single one of those sectors. We can reduce the sources. We can replace our energy system with something cleaner and more reliable. We can swap out cars for EVs and build public transit and walkable cities. We can heat and cool our homes in different ways. And what I want to point out there is that there are so many verbs: reduce, swap, build, steward the land. So many verbs, and none of them is hope. This is from the Drawdown Solutions Framework. I'm really excited that the executive director, John Foley, is speaking next. It's going to be great to hear from him. But I want to end with the notion of the hero's journey. I have 2 kids, and so I read a lot of bedtime stories. And those bedtime stories all tend to take the same, they tend to follow the same basic structure. You've got a hero. The hero goes on a journey, passes through trials, and fundamentally does something that nobody has ever done before. And that's what we have to do. We have to do something that nobody has ever done before. But my kids know that that is what happens in every single story that's worth telling. So I want to end with this. We scientists are often compared to the myth of Cassandra. So the myth of Cassandra, she was a priestess of Troy who somehow offended one of the gods. I don't know, it happens. They're all sociopaths, who cares? And her curse was that she would be able to see the future. She would be able to see the future with perfect accuracy and precision, which doesn't sound like much of a curse. Except the catch was nobody would ever believe her. And so you can see why climate scientists like me often get compared to Cassandra. So I want to end with a little passage from my book that kind of expresses how I feel about where we are. There's an obvious comparison between the mythical Cassandra and modern-day climate scientists like me. We see the tragedy that awaits, we try to warn of it. There have been 6 comprehensive climate reports commissioned by the United Nations. There have been 5 US national climate assessments. Over and over we work, unpaid, on these things. And when they're released, the news coverage is the same. Scientists concerned about global warming. Scientists worried about ice sheets. Scientists alarmed by rise in emissions. As if this were a private worry for scientists. As if everyone else lives on a different planet. And then in the aftermath, nothing happens. At least nothing commensurate with the scale of the problem. This is our curse, to shout unheard into the void, to make predictions that can't help but come true, to warn and warn and warn again until the entire world is engulfed in needless, predictable flames. But here's a tiny bit of magic. Our curse is also our gift. The models we use to predict danger and doom also show us amazement and beauty and joy. It's a wonderful thing to watch the future unfold before you, to filter the world through elegant equations until it gives you something that looks an awful lot like prophecy. But to understand the future of the planet, you must understand its present. The hot tropics and freezing poles, the climb of wet air over a damp mountainside, the gentle breeze blowing in from the sea on a hot day. You must sit there for a while, waiting for the world to show you its beautiful and terrible secrets, listening to the now for the faint echoes of futures to come. The gravity that pulls the tired autumn leaves to the ground is the same force that hurls the world around the sun. The motion of every falling leaf, a hard promise that spring will come again. It's a gift to be alive, to be able to notice things. We scientists are among the luckiest creatures on Earth. We're allowed to know. Like Cassandra, we see. But the point is not just that Cassandra was ignored, it's that she was right. Thank you.